Honorable Minister, Dr. Najma Heptulla, Dr. Pachauri, members of TERI, distinguished guests, ladies and gentlemen. First of all, let me also add my gratitude to the Honorable Minister for kindly accepting at such short notice. I would also like to thank her very much for the kind words she said about my father and also about me. And I also would like to say that her interest in science and what she just now mentioned about her interest in the universe and what's happening, the support that she is giving towards these programs, not only of the universe, but also for sustainable development, what is happening in TERI, I think is all extremely laudable. And I thank you, ma'am, for coming. I'd also like to thank Dr. Pachauri for giving me this opportunity. I'm extremely flattered and humbled that I have a chance to deliver this 13th Darbari Seth Memorial Lecture. And I saw the persons earlier who had given these lectures, and that made me feel a little, I was also at that time feeling a little bit nervous whether I would be able to rise to the expectations that the audience has of this lecture. So without further ado, I know time is short, let me just get started about the sun. What I'm going to do is first show you some dramatic, what I consider to be fairly dramatic pictures about the sun that have recently become available with the advent of spacecraft and new telescopes, then say something about the historical aspects, because I think no subject should be looked at without its past. And then we'll talk about what's happening now and what might happen in time from now. Of course, we're talking about astronomical timescales, not about timescales that we humans normally talk about, a few hours or days. So, many of you must have wondered when you see the sun, what really is going on there? Apart from, of course, the obvious fact that it gives us light, it's very important for our daily life, but what really is inside the sun? What is happening on the sun? And I thought, what better way than to show you a few recent images. This is an image of the sun taken in various wavelengths, and it shows you on the lower left corner an eruption taking place. This eruption has been caught in its glory by a spacecraft called the Solar Dynamics Observatory. The next, in this picture, you see an enormous structure which you see on the left side. This is called a prominence, and it often erupts in a most dramatic way. Just to get a feel for the size of this structure, I've shown the Earth for comparison. So you can see that this is indeed enormous. It's about 35 times the radius of the Earth. This is another spectacular image of an eruption that took place. You can see a long filament, which is about something like half the size of the sun, which suddenly erupts and creates this particular type of, you can see this eruption taking place on the sun. Another event that many of you may be familiar with is called a flare. Flares are sudden release of energy that take place on the sun. And for years, we've had difficulty trying to understand how all of a sudden so much energy can be released in a very short amount of time, something like an hour or so. And this shows you a picture, and you can see the brightenings on this disk that are taking place. This is another picture of a flare, and if you will just wait for a little while, you will see how a sudden brightening takes place. There. The last example that I would like to share with you is of what is called a coronal mass ejection, which you see on the upper right corner. This is a sudden hurling out into space of huge amounts of matter, and this material actually makes its way into the interplanetary medium and then comes and hits the Earth's atmosphere, causing different types of storms and disturbances. So it is also very important, not only as a process by itself, but about also the consequences it has on space, what we call space weather, that is the environment around the Earth. So now let me just say a few words about the historical background. And again, this subject itself, the historical background, one could just go on and on it for years, I mean for a long time. But I will just take a few examples. Let's start with our own civilization. As you know, just about every civilization, every civilization, the sun has had a special place. Start with our own. The Rig Veda says that all exists was born from Surya. Surya is the sun god, and we see Surya in this picture on his chariot. One of the most, I think, impressive sun temples is in Orissa, and this is in Konarak, where the sun temple is basically conceived as a chariot with 12 exquisitely ornamented wheels, and this chariot is driven by 7 horses. And we can see here one of these wheels. My interpretation of this wheel is, again, that this is basically, in a sense, a symbolism of the sun. Another civilization which had great reverence for the sun is the ancient Egyptian civilization. Their main god, Ra, is the sun god. And here we see an image of the Ra Horakti, which is basically the sun god and the falcon god. So it's basically showing you how much importance the civilization placed in the sun. And one of their, I think, great sun temples is in Karnak in Luxor. This is an enormous, it's an enormous structure with pyramids and obelisks, and basically the whole design of this temple was done with keeping in mind the sun, and so it's basically designed in harmony with the sun and stars. Now I would like to talk about a few ancient observatories, and I think most of us will agree that amongst the oldest, Stonehenge, which was constructed over a period of time, about 1,500 years from 3000 BC, is one of the oldest. This looks fairly primitive, but actually the alignment of the stones has a special significance. And the significance is that on the day of the summer solstice, the sun rises. In the distance, as you see out there, it rises on the summer solstice there. So this was basically a marker for basically studying the solstice. It also there have been researches on what other types of studies that you could have done at Stonehenge. Now, the pre-Columbian civilizations, the Mayans, the Aztecs, the Incas, also had a special role for the sun. And this is the Kukulcan pyramid in the Yucatan area of Mexico. Its central axis was basically designed in such a way that it was aligned to coincide with the rising sun on the solstice. So solstices, eclipses, these had very special meanings for all civilization. Of course, another factor that civilizations used the sun for. It was a marker for basically agricultural events, and as I said, it was also in addition to that a place for worship. So the sun had fulfilled many roles. This is Machu Picchu, which was this whole city, in a sense, was built by the Incas, and again, it was used to predict astronomical events, particularly the change of seasons, and which were, of course, of great importance to the Incas. Now, let's fast forward several hundred years and I'll give you basically two examples of medieval observatories. The first one is the Ulugh Beg Observatory in Samarkand. It was built in the 1420s. Tragically, parts of it got destroyed, and it remained in oblivion for a long time, till 1908. It was, in a sense, rediscovered. And the Ulugh Beg Observatory in Samarkand had a large number of instruments. It had a sextant, it had astrolabe, and it fulfilled many important astronomical functions. Of course, I don't really need to give details about this. This is our own Jantar Mantar in Delhi. It is one of the 5 observatories built by Maharaja Jai Singh. This one was built in 1725. And again, for many of you who have been to Jantar Mantar, you can see that the various alignments were used for tracking and studying heavenly bodies, and also for predicting eclipses. So now let's, having given you some historical background, now let me tell you a little bit about the sun. At a distance of 8 light minutes, the sun is basically a gigantic ball of gas consisting mainly of hydrogen and with some amount of helium. It's much more massive than the Earth. You can see the numbers out there. It's much larger than the Earth. It's much hotter. Its surface is 6,000 degrees, and its interior is much hotter. It's 10 billion degrees. And I will say a little bit about what that means to have a very hot core. It rotates like the Earth, but in a very special way. It doesn't rotate rigidly like the Earth. It rotates what we call differentially. It rotates much faster on the equator than at the poles. So it takes about 26 days for it to rotate at the equator, but about 36 days. And this, again, has very interesting consequences for the generation of magnetic fields in the interior of the sun. And its age is now fairly well established from different types of evidence to be about 4.6 billion years. It is located in our galaxy, the Milky Way, at a distance, as you can see the arrow, at about 30,000 light years from the center of the Milky Way. The Milky Way has a very large number of stars, about 100 billion or so, and there are of the order of about 100 billion galaxies in our universe, and the size of the Milky Way is about 100,000 light years. So this gives you sort of a sense of scale about our sun and its position in our galaxy. What makes the sun shine? How old is the sun? How does the sun produce the energy necessary to support life on Earth? So these questions are intimately related, and we will look at some aspects of this in the following slides. Another important question is what goes on inside the sun? What is the interior structure of the sun? These are, again, fairly profound questions, and questions which have taken a very long time in the evolution of physics for us to be able to start getting a reasonably accurate picture of what is the internal structure of the sun. How does the sun change in time? We all know that there are changes taking place, but what types of changes are these, and what is the impact of these changes for the sun as well as for the Earth and for its future? And the last one, and I cannot help say this, even though I'm not exactly an expert of this, but giving a talk in TERI, one cannot avoid the subject of what is the influence of the sun on Earth, particularly in terms of climate. The last part, I would like to mention some new initiatives that we are taking in India towards studying the sun. So this is essentially the outline of my talk. Now, how does the sun shine, and how was the sun formed? The sun was formed about, as I mentioned earlier, about 4.6 billion years from basically a clump of gas which contracted under its own gravity. As it contracted, it started heating up inside. Eventually, the temperatures were hot enough, of the order of a few million degrees, that nuclear reactions could set in, and the energy could be generated by the conversion of hydrogen into helium. And that essentially is called the radiative zone, which stretches out to about 70% of the radius of the sun, after which radiation is no longer, photons cannot and no longer transport the energy, and then energy gets transported by convection, which is very much like water being boiled in a kettle and how the energy is transported there. And finally, you come to the region which is just about 500 kilometers from where most of the light of the sun comes, which we call the surface in a manner of speaking. There is no solid surface as such on the sun. It's too hot for that. Now let's come to the sun in time. As I mentioned earlier, the sun is not constant in time. It changes on a variety of time scales. And the changes are reflected in the change in its luminosity. And this luminosity translates to the amount of energy from the sun that is falling on the Earth's surface. And that, again, controls the temperature, the climate, and so on the Earth. One of the most important factors responsible for changes on the sun are sunspots. Sunspots have been observed visually for a long time. The Chinese recorded them visually as far back as 28 BC. But the first telescopic observations of sunspots were made by Galileo, who used the newly invented telescope in 1609 to study sunspots. And on the right, you actually can see his drawings of what he saw, which are displayed here. However, if you look at the sun today with a telescope, you would see the upper picture is actually a low-resolution picture showing you the sunspots, and the lower one is a zoomed-in image where you can see a sunspot. And again, I have shown you the Earth just for a comparison of size. If you were to zoom in even further using one of the larger telescopes, you would be able to see the sunspot in its glory, where you can see the dark umbra, the fainter region outside called the penumbra, and you can see the various filaments. I don't want to go into the details about it, but one question which anybody might ask is, why are sunspots dark? This question is very straightforward, well posed. The answer, unfortunately, is not, presently, not properly known, apart from the fact that sunspots are regions of very strong magnetism. The sun has, in the sunspots, there's very strong magnetic fields. And it is now believed that the darkness of sunspots, from a physics point of view, takes place because the magnetic field, in some way, inhibits or blocks off some of the supply of energy that comes to the surface to heat up there. So the sunspots basically have less energy coming in through them as opposed to the rest, and therefore they are dark. This is, I guess, I would say, part of the story. There are some questions about it, which are still the topics of research. Now, sunspots are not, the number of sunspots at any time on the sun is not constant. They vary. This had been known for several years, but in 1844, a German astronomer looked at this problem very systematically, and he found that the number of sunspots actually increases and decreases in a very regular manner. It had a cycle with a time of 10 years. Of course, we now know today that the sunspot cycle is not exactly 10 years. It's something between 9 years and 14 years. But if you look at systematically, the variation of the number of sunspots over, say, like the last 400 years or 500 years, where we have, from 1844 onwards, we can see that the sunspots, these cycles, the sunspots have been studied every day since then. Now, does the sun influence climate? Of course, the answer is yes, but it's not so straightforward. It depends very much on the timescales that we are talking about. On a timescale of billions of years, the answer is undoubtedly yes. As we know, that the sun has gone through various stages. It has gone through a period of evolution from a clump of gas, and it's now midway. It's sort of like a young man in its life. It will stay like that for about 3 billion years, and in 3 billion years from now, its outer layers will start expanding, and they will expand certainly beyond the orbits of Mercury and Venus. Also, at this time, it is thought that it will most likely also encompass Earth, which means, I'm afraid, we won't be able to have lectures, these lovely lectures like this that we are having today, because the temperatures would have become so hot that life, but in fact, even before the sun becomes what is called a red giant, or it moves into the red giant stage in 3 billion years from now, the temperatures already would have started to rise on the Earth's surface. So it looks, it certainly is clear that the sun does play on these evolutionary timescales a very profound effect on the Earth. Now let's turn to let's reduce the time scale a little bit, and instead of talking about billions of years, let's talk about millions of years. It's well known that the Earth has had 5 major ice ages. The first one took place around 2 billion years, and we are actually in an ice age which started 3 million years ago. However, in these ice ages, there are periods of alternate warm and cool periods called interglacial and glacial, where the temperatures are warmer or colder. And we are presently in an interglacial phase, which started about 11,000 years ago. What causes these factors physically? There are basically 3 factors. One is the precession of the Earth around its axis. The second is the change in the orbital inclination of the Earth with respect to the ecliptic. And the third is the variation in the distance between the Sun and the Earth. And these are factors which influence the climate. Now let's come to time scales. Let me move on a little bit faster. Let's now move on to time scales of hundreds of years. On time scales of hundreds of years, the connection between the sun and the climate has been fairly well established. I don't expect you to go into the details of this figure, but it shows that there certainly is a correlation between the Earth's climate and solar activity. Now, estimates that have, before I come to that, I'm sorry. Estimates by the Intergovernmental Panel on Climate Change, of which Dr. Pachauri has done pioneering work, has shown that over the last century, the average temperature on the Earth has gone up by about 0.8 degrees. And particularly in the last 40 years, there has been a trend that the temperature is gradually rising. And so these are factors which are to some extent, you have to isolate what is the solar influence and what is the human influence. And at this point, the general feeling is that the human influence is certainly having a major role to play in the short time scales that we are talking about. In the last part of my talk, and I'm so grateful for the Honorable Minister for staying for so long, in the last part of my talk, I would like to talk about a major national initiative that we are taking in India, and that is to build what will be the world's largest solar telescope on Indian soil. I mean, it'll be the largest solar telescope in the world, and it would be located on Indian soil. It would have several objectives. I'm not going to go into the details of that because there's a shortage of time, but it would be able to look at very tiny features on the sun of the size of something like 70 kilometers, which is in fact a very small distance when you look at the sun from so far away. It will be located in the Jammu and Kashmir area of Ladakh. We are waiting for formal clearance from the government. It has reached its final stages, and we hope that once that clearance comes, this telescope we will be able to complete this telescope in about 3 years or so. So by about 2018 or 19, we should have this facility in place. So having, I think I have more or less covered the time allotted to me, I would just like to just quickly summarize. The sun is a cosmic powerhouse that has a profound impact on our planet and its future. It displays a range of activity, which I already presented before you, and this affects the Earth's environment. The solar emissions change with time, with the sunspot cycle, as well as with longer time scales of centuries to millions of years. The sun influences the global climate on Earth. However, as I mentioned, there are also human factors which need to be considered. And finally, a unique world-class facility for studying the sun is expected to come up in the country in the next few years. Thank you.